Hi everyone, we will be doing a few examples for one-dimensional motion in this lecture. Now to be more specific, we'll be focusing on problems for constant acceleration motion. So we know there are 5 kinematic equations that we can use for constant acceleration motion. So how do we solve those kind of problem? There is a simple strategy. First, write down all the known quantities in the problem, and then identify what are you being asked to find. Finally, look at your list of equations and find the one equation that connects you the known quantities to the unknown quantities. This table here is a great guide. It shows which variables are in each equation. So as long as you can find the 3 known quantities, you always can guarantee to find the equation that can help you solve the unknown. So we want to watch a few movie clips.
Yes, sir. Yes.
Where did you find religion?
Will you assign me this mission, sir?
I want you to do me a favor.
What's that, Colonel?
Pray for both of us. Let's go! Max power! Come on! Come on!
Jesus, that was short. All right, full power, here we go!
Come on, here we go! Here we go!
Okay, so that's one of my favorite movies, Pearl Harbor. So I want you to think about why it is much more challenging to have this airplane take off on an aircraft carrier compared to airplane take off on a regular airport with much longer runway, and why, if you watch the entire movie, why they have to make their airplane as light as possible. They even throw away the machine gun from the airplane, even though they are flying to the enemy territory. Okay, so that's something that I hope you can think about. So we're going to do a related example. Airplane takeoff. The speed for the takeoff is 360 kilometer per hour, and its average acceleration is 2.4 meter per second squared. We want to find out how much time is it accelerating down the runway before it can take off. So which means at the very beginning, the position is 0, right? Initial velocity is 0. We know the acceleration is 2.4 meter per second squared. So how long does it take for the airplane to reach its takeoff speed, which is 360 kilometer per hour? But first of all, we need to convert this kilometer per hour to meter per second. We want to turn everything into SI unit first. So what are the known quantity? We know the initial position, initial velocity, and this I would call it the final velocity, right? Acceleration. And we want to find the t. So we're going to find which equation, kinematic equation for constant acceleration motion contain those variables. So final velocity, initial velocity now, acceleration now, and then we want to solve for t. It looks like this is exactly the equation we are looking for that can help us solve this problem. Because if you plug in the known quantity, you just have one variable unknown, so you can solve it algebraically. Okay. Let's apply this to this problem. So we decide we would use this equation to solve this problem. V0 plus AT. And final velocity, as we already converted, (360 km/h) is 100 meters per second. So this is 100 meters per second. Initial velocity 0, acceleration 2.4 meters per second square, and t. So t is 100 divided by 2.4. If you check the unit second, works out. And the final answer would be, let's see, 41.67 seconds. That's how long it takes. Okay. Now this problem asks what is the distance the airplane travel on the runway before it takeoff. So we have the same known quantity. Initial position, initial velocity, final velocity, acceleration. We want to find out the displacement. So which equation has all of this? Final position, initial velocity. We don't really know time, right? Don't know. Acceleration. Yes. Time. Yeah, this is what we're looking for. So we have two unknown if we want to use this one. But of course, you can argue we already found out the t, so you can use this one if you solve the t from previous question. But if we didn't find the t, how do we solve it? We can follow this. See, we know final velocity, initial velocity, acceleration, displacement. Okay? So this equation can help us solve this problem. So plug in all the numbers. So we have final velocity, subtract initial velocity equals 2 times a distance. So the distance traveled, or maybe we call it x, right? We call it x. X is the distance airplane traveled, equals to v squared, v0 squared, 2a. Final velocity is 100 squared, initial velocity 0 squared, 2 times 2.4. The mass per meter. So plugging all the numbers, we find it a little bit over 2,000. So if you want to make it a aircraft carrier, the runway on the aircraft carrier has to be more than 2,000 meters. That's why it's a little bit challenging to build a large aircraft carrier, but it's necessary. Okay. Now we move on to our next example, which is kind of related. So the first one is taking off. The second one is landing. A typical jet lander lands at a speed of 160 miles per hour and deaccelerates at the rate of 10 miles per hour per second. If the plane travels at a constant speed of 160 miles per hour for 1 second after landing, constant speed for 1 second, And before applying the brake, what is the total displacement the aircraft traveled between touchdown on the runway and coming to a full rest? So this motion has two parts. First part is constant speed. Constant speed. Second part, constant acceleration. Okay, and we really want to do the unit conversion first. We really want to do the unit conversion, change everything to SI unit before you do the calculation, or save a lot of hassle for us from the beginning. So how to do this? We want to convert to meter per second. So I do want to do it one more time, even though we did the example on this from chapter 1. Let's do it one more time. So this is 160 miles per hour. We want to convert to meter per second, right? So we want to multiply 1. So this is mile. We want to get rid of mile. So I will write 1 mile here. And what I want to keep meter. So I need to convert 1 mile to meter. 1609.3 meter. This is nothing but 1. So 160 miles per hour times 1 is 160 miles per hour. Now do the same thing. I want to get rid of this hour and change it to second there. So I would have 1 hour here. It'll be 3,600 second. So now see the hour cancel, mile cancel. The unit is meter per second. Plugging all the numbers is 71.53 meter per second. And then acceleration is 10 miles per hour per second. Okay, so I'm not going to do this conversion step by step, but just present the answer should be 4.47 meter per second square. That's the acceleration. And notice the acceleration is in the opposite direction of the speed. If speed is positive, speed is in the positive x direction, then acceleration should be negative. Okay, now we solve this one. So we need to calculate those two distance. Let's call it this D1, call this D2. Okay. How to calculate D1 and D2? So D1 is a constant speed motion. So the only kinematic equation for constant speed motion is just v times t give you displacement. So it's 71.53 times time, which is 1 second. The displacement is 71.53 meter. D2. Now D2 is a constant acceleration motion with initial speed 71.5, final speed 0, acceleration minus 4.47, and looking for displacement. And so we need to check which equation has this, right? So of course, we're expert now. It's final speed, subtract the initial speed square, equals 2a d2. You can also call it x2. Okay, now d2 equals vf square, v0 square, 2a. Plugging all the numbers, we find is 572.32 meter. So 572.32 meter. So the total distance, this distance, let's call it d, equals d1 plus d2 equals 643.85 meter. And this is the final answer.